Hello, and welcome back to the channel. This is the first episode of our journey to the functional programming in JavaScript. And the previous one is, well, dismissible, if you'd like, because that was basically the introduction to it. So in today's episode, I'd like to discuss three major concepts in JavaScript when it comes to functional paradigm. That's going to be function as a value, higher order function, and function currying. And I will provide basically two examples to show you those concepts. So I decided to not use codepen.io for the web IDE. I find out that Code Sandbox, as you can see here, is, and let me bump it up, is way more approachable. So this is basic vanilla JS code sandbox, nothing fancy here. And to introduce those concepts, we need a little bit of data. So I'm going to create a new array JS, or maybe functional part 1. Yes, sounds reasonable. And I'm going to copy some data here. This data is an array of objects, something the structure very well suited to explain programming, functional programming. As you can see, this is an array that has objects in it, and we have ID, name, genre, excuse my English, and a logo for each of the games. Maybe you recognize some of these. Okay. So let's start by explaining what is function as a value. Well, JavaScript and many other programming languages, we think of value as something that we can store in our variable. And it's very natural for us to store objects, values, stuff like arrays. That's reasonable. It's like a variable is like a box where you put something in, and often you imagine that being a thing, then something that you might do. Because if you could use that simplistic separation, the objects are things in programming, and functions is, well, some kind of operation that you do. Okay, and let's take a look at a very simple example where I would like to find out what types of games have a specific genre. Okay, so let me open console because I'm going to be using that. So let's say I would like to find FPS games. Well, that would be rather easy because if I go into the properties of my array, I can see that it has lots of methods built in there. Stuff like filter, map, and reduce will be of particular value for us. So if I'd like to search through the array and find the objects in it that fulfill some kind of condition or predicate, filter looks reasonable to do that. And then I can iterate over each and every genre to find the FPS games. Now, of course, we can just simply log this out, and if we just attach that, C functional part 1 JS. Definitely not here, but rather here. Yeah. And we found out those two games that are of given genre. But so what we have here, close this, no, not really. So what we have here is a function into which I pass some code that is telling how should we filter out stuff in our array, okay? And this is, as you might know, anonymous function and also an arrow function. And we love arrow functions in functional programming. But what you can do with a function is actually store it in a variable, okay? So I could rewrite that simply saying, is FPS game, game, and check whether its genre is equal to FPS. Okay, and now I can pass it here. And basically, that would be it. Treating functions as a value mean that you can pass those functions into another functions just like any other argument. And this opens a whole new world when it comes to programming. Because now, instead of searching for a very concrete solutions, you can abstract away parts of your complicated functions by passing into that way simpler function. That function is, well, as simple as it can be. It just checks whether the property in an object is equal to something, right? And of course, I could create another simple function like that to compare with another game genre. I don't know how to say it, okay, but you get the drift. Of course, filter is not the only higher order function that is built into an array. Let's imagine that I'm getting this data from some kind of API, and what I need is to display all the images. Therefore, the array of URLs for that images could come in handy. So what I could do is write game logos, and we can transform one array into another using map. So I could say game return game logo, and let's just write that. Okay, and here you can see I have the array with the URLs and also one undefined because for Phoenix Point we don't have a logo. So far, so good. But as you can tell, these functions, well, they're like one purpose only. Find whether this is FPS game, find whether this is TBS game. But we could improve that by simply adding another argument to our predicate function. Is game of type. I could just do this and compare it like that. That looks way better, right? And now I can check for game genre in a little bit more elastic way. Okay, so I could do is game of type games 0 and check for FPS. And here I'm getting False, because game of 0, well, it is FPS. Is game of type game general TBS game 0. Something is of course wrong. This is not used. Is game of type. Oh yeah, I should be doing this live. FPS. The order is inverted. Now we get it as a true. The problem here is I can't really call my map or my filter with that function because, well, it is taking 2 arguments, and here that function gets only 1. So there's a mismatch between how many arguments I should pass to higher order function, which is a function taking another function, and how is my very elastic function written, right? So here comes the concept of returning function from function. Okay, not only you can treat a function as a value, but you can return function from another function. So let me show you an example. The simplest I can think of. So one thing you can do is write a very simple function like we did. And it will work very nicely. It's taking 2 arguments and just adding those. Okay? And as you can imagine, you would call it like this, which would result in 7, which is great. But what if I would like to write a function that can be reused and repurposed for many problems that we may encounter in programming? Okay. Well, there's a concept. There are 2 concepts actually. There is a partial application and there's currying. And we'll discuss currying here and partial application, I hope, probably later. So instead of writing our function like that, I could say, write this like this, return well, should I write this like this? Return, no, not like this. Actually, yeah. Okay. Function that is taking E. We're going to return a function taking B. Return A plus B. Did I write this correctly? Add has already been declared. Okay, so I have a function that is taking 1 argument, and then it's returning a new function that's taking another argument, and then it returns the sum of those 2. So this kind of syntax now allows me to call my function, or let's maybe call it Curried add. And Curry, I believe, was a mathematician, if I remember that correctly. I could call it like this, and I'm getting my result. So let's try to figure it out for a moment. I'm calling my function with the first argument. It will not return any kind of operation because there's no second argument to it, but it will return, it will return another function that can take another argument here. So this is my A and this is my B, right? And then it returns a function that sums up, well, it returns the finished operation, the sum of those two arguments. Okay, and this can be rewritten a little bit better. So I can do Curried app can be written a little bit shorter thanks to the arrow functions. A returns B returns A plus B. Okay, and as you can see here, right, let's just try it again. Like 5 and 10. Okay, but what about the case where I only apply one argument? It returns a function. Okay, as you can see right here. Therefore, I can use its syntax to create concrete functions from a function that can be repurposed. What I mean, I could create a function, let's say at 66. Okay, this is not going to be result, any kind of result of addition, right? Because I pass only one argument. What I have here is another function that can be used again many times by passing a different second argument. Right? So I can create functions from functions. Okay, well, this is great because you can take one function and, as I mentioned before, repurpose it or refit it to your need. The problem is, well, there are many problems with this. So let's say I would like to create a function that now does the multiplication. Okay, the standard function would look like A times B. Okay, and the current version is of course A returning B returning A times B. The very same as before. So there's a pattern here, and maybe we can write a higher order function that is taking a function that is using two arguments and carrying it automatically. So let's figure that out. I'm gonna create a carry function, and let me figure it out. So what I basically need here is a function that will take another function and then first argument and second argument and apply those arguments to my function. That sounds reasonable. So let's create one. So we'll start with a function, then we'll get first argument, we'll get second argument, and nothing simpler than just applying those to a function. Okay, so this operation is called currying, taking a function, then you return a function that takes first argument, second argument, and then applying it. So let's try this out. I'm gonna say better curried add just curry, and what we will pass here is not a curried add that we created here, but standard add here, right? And if my assumptions are and calculations are correct, it should work. Console.log better curried add, and now I should pass 10 and 30 and get 40 over here. Okay, so I can do the same with multiplication. Const multiply. Let's say const better curried multiply. Okay, and it's gonna be curry multiply, and let's check that out. Better curried multiply 10 and 20. Okay, and of course I can still use that to create well, the concrete functions. So let's say multiply 100, that is better curried multiply 100, and then I'm gonna use multiply 100 and do it like this. Okay, so far so good. What can we do, or what should we do, if there's a function that is a little bit more complex? For example, I would like to use great multiply. There's that will take 1, 2, 3 arguments, and I would like to curry that. Well, as you can imagine, I could extend my curry function, or you can easily find out how to implement curry function for any number of arguments. But code for that, well, it's a little bit hard to understand. What is helping us a little bit here is that you can add any dependency like Lodash or lambda. Let's see, do we have it? There's a Lodash. Import underscore this import everything as from Lodash. Oh, naming is to this to underscore is like the historical thing, right? And we have our great multiply here, and great curried multiply great multiply is like equal to, and here you will find lots of stuff, things like chain, which is going to be helpful for us, also carry. Okay, and here I can just pass great multiply, and the result of that, say 2 times 4 times 5, that should be 40. Okay, and the result of that is a curried function, no matter how many arguments you pass there. So the function can take 5, 6, any number of arguments. Okay, so why is all of that important? Going back to our games example, knowing that I can change my isGame of type a little bit and write it like that. Curried isGame of type, not that, and game, and compare those two. Pretty much the same, except for the fact that this is Curried. Okay, so now I can use it like this. TBS games. This is games filter. Curried is game of type TBS, and let's console.log TBS games. I have two of these, and this is of course XCOM and Phoenix Point. Okay, so this is how you can use function carrying to your advantage when working with higher order functions, right? You can just partially apply that, and this is really nice and really extensible. And as I mentioned before, you don't have to repeat yourself, because now getting the FPS games, just a matter of changing one thing. Where is, I did something wrong. FPS games has already declared, of course. Escape from Tarkov and Doom. Okay, and this is nice example, but I wanted to show you another one, this time including some kind of DOM and outputs. So let's go to index.js. I'm going to disable that one. I'm gonna get rid of this and provide you with another example. Okay, so let's create a very simple, let's clear, this is cleared, this is unused, let's just comment that out. And this is not used. I just want no problems in my life. Okay, let's write a very simple function. We're gonna call it show me the output. Okay, and let's go just showing some output. Okay, and we're gonna run it. So show the output. Okay, working so far so good, but this function isn't really complex or somehow extensible. Okay, so let's change it a little bit. I would like to decide what is my output. It can be a console, which is great, or maybe I would like to add it to some kind of HTML element. So I'm going to just add something like ID output, which is going to be empty for now. Can I drag this? Thank you. Thank you. But as you can see, it's here. Okay, so then I would like to decide where to provide stuff, where to output my stuff, sorry. So I'm gonna just do document query selector output text content showing some output. this is not going to work because we have a true here. So maybe you should show in console, something like that. And then since this is false now because it's undefined, it's gonna show in our HTML, but if I change it to true, it's gonna show here. So just to show you, right, this is showing here and here. But again, this is not the greatest thing in the world. So maybe we could pass different text here, right? And then reuse it here and here. Okay, so this is like a little bit better. Hello from console and hello from HTML, of course. Okay. So this is slightly better, but maybe what we could do is to change it and make it a higher order function that is taking another function, and that function is simply informing the higher order function where should the output come from. And you will see that it's by doing that, we're splitting our code into simpler chunks. Okay, so let's try that. I'm gonna go right here and say, show me the output fn, like functionally. Okay, so what we're gonna do this is take a function here that will get our output, and we're gonna take our text, and we're gonna just simply pass the text to the function that is taking the output. Really easy. And now I could call it like that. Show me the output functionally, pass the function for an output, and text functionally showing output in console. Okay, this is working great. And now, since this is the information where to get the output from, or what should be the output, we're just writing a simple function with the second argument. This is reusable and this is extensible. Okay, so let's try reuse it with our HTML. Okay, so let me think. Let's create HTML output function here. Okay, and it's going to take a selector, because what could happen is we might have another output here. Okay, HTML output selector, and what should we do, right? Well, we should basically do stuff like document get how do you query select, of course, query of the selector, and then what, right? Well, I would like to apply some text here. So the simplest way you could do that is just to provide another text argument. Say text content is a text. Okay, that's really good. I could now call it like HTML output. Selector is and then this is paragraph. Nice. It's all working. Let's get rid of that. The problem is, can we use that function with our show me output functionally? Well, not really, because we have arguments mismatch, and this is called rarity. No. Well, there's a name for that. Well, it doesn't matter. So can we rewrite that to make it so that we can use it with our show me output functionality? Well, of course, we can carry it. So we can create a function that is returning another function. And then text is not defined, text is defined. Then I could run my show me output functionally like that. HTML output, pass a p, and this is functional paragraph. Okay, so again, we're carrying our function to match the arguments that we need for the higher order function. Okay, and this is of course reusable, so that I can pass just another output. What was our selector here? Output. This is functional div. Okay, so this is it. This is the basics of functional programming. So stuff like functions as a value so that you can reuse them. Using the higher order functions that are taking, where do you have it? That are taking the function as an argument, right? And then of course, carrying the functions to make the function return another function, which allow you to create reusable functions. So I could do something like, I could do something like this. Add output to paragraph. Okay, and then we'll add output to paragraph with I will do functional programming. And as you can see, it's working. Okay, so thank you for that, and I'm going to see you in the next episode. Goodbye.